Section 2.3, Applied Functions, Variation. There's a few different types of variation. The first one we're going to look at is direct variation, which would be of the form y equals kx, where k is a constant, a number, that is not 0. This could be worded something like y varies directly as x, y is directly proportional to x, or y is proportional to x. Direct variation is basically just a linear equation with the y-intercept 0. Here's an example. During a thunderstorm, you see the lightning before you hear the thunder, because light travels much faster than sound. The distance between you and the storm varies directly as the time interval between the lightning and the thunder. So let's go ahead and look for some key terms here. Varies directly, and it's distance that varies directly as the time interval between lightning and thunder. So distance varies directly as time. So if we go back and look, it's y varies directly as x. So distance varies directly as time. We'll use t for time. So suppose that thunder from a storm 5,400 feet away takes 5 seconds to reach you. Determine the constant of proportionality and write the equation for the variation. The constant of proportionality is just the constant, the k. So we're going to plug in the information we know. We know distance is 5,400 feet. We're going to solve for k, so k will be in our equation. And it takes 5 seconds. And then we are determining the constant of proportionality, so we're solving for k. So we need to divide by 5. $5,400 divided by 5 is 1,080. So k equals 1,080. Now sketch a graph of the equation. Oh, we still need to write the equation for the variation, so plug that back in. So distance equals 1,080 t. Sketch a graph. What does the constant represent? So our graph will look something like this. Distance and time, and what this 1,080 is going to do is going to act like our slope, since this is a line. It means it's going to go up 1,080 feet every second. So 1, we'll put 1,080, and then we'll go up another and double that to 2,160. And for time, we'll go over to 2. So at 0, 0, 0, 1, 1,080, and 2, 2,160. So our sketch is something like that. What does the constant represent? That's basically slope. It's how many feet per second in this case. If the time interval between lightning and thunder is now 8 seconds, how far away is a storm? So we're going to use our equation, d equals 1,080 t. but now time is 8 seconds, so d equals 1080 times 8, and that gets us, the distance is 8,640 feet. That's about 1.5 miles. Another type of variation is inverse variation. That would be a y equals k over x. Again, k is a constant, a number, cannot be 0. You could read that or recognize an inverse variation function by y varies inversely as x, or y is inversely proportional to x. An inverse variation function looks like this. So here's an example. Boyle's law states that when a sample of gas is compressed at a constant temperature, the pressure of the gas is inversely proportional to the volume of the gas. So the pressure of the gas is inversely proportional to the volume of the gas. Pressure is inversely proportional, K over the volume, K over V. Suppose that the pressure of a sample of air that occupies 0.106 cubic meters at 25 degrees Celsius is 50 kilopascals. Find the constant of proportionality and write the equation that expresses the inverse proportionality. So the pressure of the sample is 0.106, that's pressure. 0.106 equals K, that's what we're going to solve for, the constant of proportionality, over, oh, that's not pressure, that's volume. The pressure is 50 kilopascals. The volume is the cubic meters, 0.106. So to solve, we can think of that as being over 1, cross multiply, so 50 times 0.106 is 5.3. So to write the equation, pressure equals 5.3 over volume. If the sample expands to 0.3 cubic meters, find the new pressure. So the volume goes up to 0.3, find the new pressure. 5.3 over the new volume is 0.3. We get 17.6 repeating, and pressure is measured in kilopascals, kPa. The third type of variation we're going to look at is called joint variation. That involves 3 variables. Z equals K times X times Y. Again, K is a constant, not 0. You can read this as Z varies jointly as X and Y, or Z is jointly proportional to X and Y. You can also combine all of these variations together a little bit. Here's an example with that, where we combine a direct and inverse. Z equals K times X over Y. For that, would read that z is proportional to x and inversely proportional to y. Because it's basically two equations at the same time. Z equals kx and z equals k over y at the same time. Newton's law of gravitation is a combination of all these variations that Newton came up with a long time ago. Newton's law of gravitation says that two objects with masses m1 and m2 attract each other with a force F that is jointly proportional to their masses and inversely proportional to the square of the distance r between the objects. Express Newton's law of gravitation as an equation, and for this we're going to use a capital G as the constant instead of k. So we have force is jointly proportional to their masses and inversely proportional to the square of the distance. So if it's proportional to their mass, that means we have F, remember we're using G as our constant, proportional to their masses, so their masses are m1 and m2, and inversely proportional, so that means over the square of the distance r. So the square of r squared, between the objects. So that's it. F equals G, the constant, proportional to their masses on top, and inversely proportional to the square of r squared on the bottom.